This is going to be the key to the practice final exam for the spring 2021 semester. So for number 1, solve the equation. We have 1a and 1b. So for 1a, we're solving this equation. It's a radical equation. So we would start by trying to get rid of the cube root. So we would cube both sides. And that would give us 5x squared minus 6x is equal to x cubed. Then at this point, since we have an x to a power, we're going to get everything to the same side of the equal sign and set it equal to 0, and then see what we can do from there. Since our x cubed is positive, I'm going to move everything to be with that because I want my first term to be positive. So I'm going to subtract 5x from both sides, or 5x squared, and add 6x to both sides. So that will zero out, and I will have x cubed minus 5x squared plus 6x is equal to 0. Now I will try to factor, so I can see that everything has an x in common, so I can factor out an x, and I will be left with x squared minus 5x plus 6 equals 0. And now I can try to factor what's in parentheses again. So I'll bring this x down. I'm going to factor what's in parentheses. It's a trinomial. There's not a number in front of the x squared, so that coefficient is understood to be a 1. So we'll split it up with x, and we have to figure out what multiplies to get negative 6 and what adds to get negative 5. So what multiplies has a product of 6, and what adds or sums to negative 5. So if we try 3 and 2, and we think about two negatives, a negative 3 times a negative 2 is a positive 6, and a negative 3 plus a negative 2 is a negative 5. So that works. So now we can set each factor equal to 0, and then solve each linear equation. So x equals 0 is the first solution. We want to add 3 to both sides to isolate the x. So that'll give us x equals 3. And then on the last one, we would add 2 to both sides, and we would get x equals 2. Go ahead and get in the habit of checking your answers for the ones with radicals. So since we started with a radical in this equation, you want to check your answers. So prior to boxing them in and saying that they're answers, you want to check them. So we're going to check x equals 0 first. That means we're going to plug 0 in and see if we get a true statement. So 5 times 0 squared minus 6 times 0, we're going to take the cube root of that, and we're going to say that it should be equal to 0. 0 squared is 0 times 5 is still 0. Negative 6 times 0, 0. So the cube root of 0 is 0. So 0 is equal to 0. That's a true statement. So x equals 0 is a solution. And then we're going to check x equals 3. I'm going to go over here so I have more room. So if I plug in 3, I'll have the cube root of 5 times 3 squared minus 6 times 3 is supposed to be equal to 3. So 3 squared is 9 times 5 is 45 minus 6 times 3 is 18. So that will be the cube root of 27, and the cube root of 27 is 3. So that also checks. So 3 is a solution. And then we're going to check x equals 2. So we'll have the cube root of 5 times 2 squared minus 6 times 2 is equal to 2. So 2 squared is 4 times 5 is 20 minus 6 times 2 is 12. 20 minus 12 is 8, and the cube root of 8 is in fact 2. So that also checks. So 0, 3, and 2 are all solutions to this equation. Okay, for 1b, find the x-intercepts of this function. So remember, if you're finding x-intercepts, this means you want to let y equal 0 and then solve. Remember that g of x is the same thing as y. So that means we're just going to set the right-hand side equal to 0. So the cube root of 5x squared minus 6x minus x is equal to 0. And we want to solve this equation. So before you start solving a radical equation, you should make sure that you have the radical by itself on one side of the equal sign. So right now I have the radical and then minus x. So I need to first move that x over to the right-hand side by adding it. So that will give me the cube root of 5x squared minus 6x is equal to x. And so now at this point I would be ready to get rid of the radical. But if you take a moment and look at 1a, you will see that that's actually the exact same equation that we just solved above in 1a. So we already know the answers to that. So the answers are x equals 0, x equals 3, and x equals 2, because that's what we got above. The only difference here is that they want us to give the x-intercepts. So rather than just give the solutions or the zeros, now we're going to give the intercepts. So we need to put them in an ordered pair. So 0, 0. The next one, x is 3, y is 0. And the last one, x is 2, y is 0. There are the 3 x-intercepts. So no more work had to be done really except putting them in intercept form, and that was it. All right, number 2, determine the least possible degree of the polynomial function graphed below. So really what you're looking at here is you want to count the hills and the valleys, so all the turning points. And if you count the turning points, you add 1 to that number, that gives you the least possible degree. So the turning points, it's like the relative minimum and maximums. So we have a turning point there, that's 2, 3, 4, 5, 6, 7. So we have 7 turning points. Okay, so that means the least possible degree is 8. You always just add 1 to however many turning points you have, and that's the answer to that question. Number 3, find the inverse of the function. So for this one, f of x is the same as y. To find an inverse, you first interchange x and y, then you solve for the new y. And that's going to give you your inverse. You can also write it in inverse notation. So f inverse of x equals, instead of leaving it as a y. But once you finish step 2, you found the inverse. So here we want to interchange x and y. So we're going to have x equals the cube root of 10 minus y. And now we try to solve for y. So we have the radical by itself, so we can undo that by cubing both sides. So we will get x cubed is equal to 10 minus y. Now we're going to subtract 10 from both sides. So that will be x cubed minus 10 is equal to negative y. We still don't have y by itself because of that negative, so we need to divide both sides by negative 1. And that will end up giving us y equals a negative x cubed plus 10. So if you get to that point, you have found the inverse. And if you really want to be awesome, you can write it in this form. So f inverse of x is equal to negative x cubed plus 10. I think realistically you would get full credit if you put it in either form, but if you wanted to put it in the inverse function notation form, you could do it like that. All right, number 4, divide the polynomial by the given factor. Clearly state the quotient and the remainder. So, let me go back to number 3 real quick, sorry. So remember that these are just, examples of what could be on there. There could be some kind of variability in what appears on the final. So number 3, this is a good example to look at. We did a lot of these, find the inverse of things with radicals, but we also tried to find the inverse of fractions a lot in your homework. So make sure you go back and you look at how to do that as well. Okay, so number 4, this is another one where you can think of 2 different ways to solve this. You can use long division, or you could use synthetic division. So here, since you have a linear factor that you're dividing by, that doesn't have a coefficient in front of the x, the easiest way to do this is with synthetic division. So for synthetic division, remember you're dividing by this. This is your factor. You want to use your 0 for division. Remember that the 0 is always the opposite sign. So we're going to be dividing by -1. And then we are dividing the polynomial given here. And what we're looking for is any missing terms. So we start with an x cubed, and then we should see x squared. X squared is missing, so we're going to put in a plus 0x squared as a placeholder. Then we should see x, we have that, and then we should see a constant, we have that. If you're missing any terms, you need to make sure you put a 0 placeholder or it will mess up your answer. So we just use the coefficients, so 3, 0, -7, and 2. And then from there, we bring down the first number, and then we do the mama, multiply, add, until we get to the end of the row. So -1 times 3 is -3. Then we add straight down, and we get -3. Multiply, -1 times -3, we get +3. Add straight down, we get -4. Multiply -1 times -4, we get +4. Add straight down, we get 6. So now we have come to the end of the row, so that's all we have to do there. Now we just have to make sure we label correctly. So I like to put a box around my last number to kind of separate the two. The box goes around the quotient, and what's before that is, the box goes around the remainder. What's over here to the left is the quotient. So you want to make sure you label them. So you have the quotient, you have the remainder. The remainder is 6. It's always your last value. Your quotient, remember that what you're doing is you're bumping this down a level. So if you started with an x cubed, you're going to end up with an x squared and an x here. So that means we're going to have 3x squared minus 3x minus 4 as our quotient. Make sure you label them. It says to do that in the directions. Clearly state them. If you don't and you just do synthetic division and leave it at that, you're not going to get credit because you didn't clearly state the quotient and the remainder. We don't know if you know what those are if you simply just do the synthetic division. So do make sure you label them and are very clear with your answer. All right, number 5, find the equations of the horizontal and vertical asymptotes for the function given. So whenever you're doing these, the first thing you want to do is try to factor the numerator and the denominator in order to see if it can be reduced. So let's do that. So the denominator is a difference of squares, so that's going to end up being x minus 2, x plus 2. The numerator, we're going to have to do a little bit more work to figure out how to factor that. So this is a trinomial. We have a coefficient other than 1 in front of the x squared. So we're going to do the factor by grouping process. So we want the product to be 6 and the sum to be -7. So our options are 1 and 6 and 2 and 3. That's the only way to multiply whole numbers and get 6. And now we want to play with the signs. So 2 and 3, if we add or subtract those numbers, it's not going to give us 7, so that's not it. It's got to be 1 and 6. If we make both of these negative, -1 times -6 is +6. And -1 plus -6 gives us -7. So that's going to be the numbers that we want to use. So we're going to bring down the 3x squared, and then we're going to use the -1x and the -6x to rewrite that -7x and bring down the +2. And so now we're going to do factor by grouping. So what's in common with the first pair? X. When you factor out x, you get 3x minus 1 left. Bring down the minus. What's in common with the next pair? 2. When you factor out a -2, it's going to change the signs. So we'll have a positive 3x minus 1 left. So you can see that we have 3x minus 1 in common now, and then x minus 2 will be the other factor. So the numerator factors into 3x minus 1 times x minus 2. Hopefully you can see why that was important to do, because we have x minus 2 in common. There's one on the top and one on the bottom. So those will actually divide out to 1, so we can cancel those out. We'll have 3x minus 1 over x plus 2 now as our reduced fraction. It doesn't ask us to find this in this question, but it possibly could ask for this, on the final. The part that we just canceled out is called a removable discontinuity. I referred to it as a whole. That means the same thing. You have a removable discontinuity at this point. So if you solve this, you get x equals 2. So at x equals 2, you have a removable discontinuity. Now to find the asymptotes, we use the reduced fraction. So we use this to find asymptotes. Okay, so 2 asymptotes we have to find. It's going to have a vertical and a horizontal. So the vertical asymptote is the one that's more straightforward, so we'll start with that. You set the denominator equal to 0 and solve. So our denominator is x plus 2. So x plus 2 equals 0. To solve, we subtract 2 from both sides, so we get x equals -2. That is the vertical asymptote. You have to make sure that you write this as an equation, x equals whatever number it is. If you don't write it as an equation, then you do not get credit for this. An asymptote is an imaginary line, okay? It's a line that's there, so it has to be an equation. You cannot just put VA equals -2. That's not correct. It needs to be x equals -2. Okay, then we're going to have the horizontal asymptote. There are cases to this. This is the case where the degree of the numerator is equal to the degree of the denominator. Remember that the degree is the exponent, the highest exponent in the polynomial. So on the top, the degree is 1 because that's the exponent on the x. On the bottom, the degree is 1 because that's the exponent on the x. So if the degrees match, your horizontal asymptote is always going to be y equals the ratio of leading coefficients. So you have to look at the leading coefficient on the top and the leading coefficient on the bottom. The coefficient is the number in front of the leading term. So the coefficients are in front. So on the top, the coefficient is 3. On the bottom, the coefficient, there's not one written, so it's understood to be a 1. So y equals 3 over 1, or we reduce that, and we get y equals 3. That is our horizontal asymptote. Horizontal asymptotes will always have an equation y equals. Okay? Vertical is always going to be x equals because that's a vertical line versus a horizontal line. All right, so there are your answers for that one. Let me go ahead and really quickly look at something else. So that was one case for the horizontal asymptote. Again, remember that they could have the other cases on the final exam. So if you have, let's say, some other function where you have let's not use 3. Let's say 5x over x squared minus 8. So let's say you have this function, and they ask you to find the horizontal asymptotes. So if you want to find the horizontal asymptote, you want to look at the degree. So in this case, the degree of the numerator is 1. The degree of the denominator is 2. So the degree of the numerator is smaller than or less than the degree of the denominator. If that is the case, then your horizontal asymptote is always y equals 0. You don't have to do any work at all. You just know it's y equals 0. Those are the two cases for a horizontal asymptote. The last thing, so there's another case. The other case is, let's say I had, let's say I have that function, this h function. Notice here, the degree of the numerator is bigger than the degree of the denominator. So the degree of the numerator is greater than the degree of the denominator. In this case, you will not have a horizontal asymptote. You will have a slant asymptote. And to find the slant asymptote, you use synthetic division and divide, and then you get your slant asymptote. It'll be y equals whatever you get, your quotient, from synthetic division. Ignore the remainder. So you literally just cross off the remainder and ignore it, and just say y equals the quotient, and that would be your slant asymptote. Okay, so let's look at number 6. So 6 has two parts, part A and part B. Part A, solve the equation. So we talked about two different methods to solve logarithmic equations. One method is to try to consolidate everything into one log. So if you have a bunch of logs on one side, or if you just have one log to begin with, you can simply rewrite the equation in exponential form and go from there. The other option is to get one log on each side, and then the logs will undo each other. So that looks like what we're going to do here in part A. We have logs on both sides. So I'm going to try to condense each side into one logarithm. So if I'm looking at the left side, we have the property that says if you have the sum of multiple logs with the same base, you can combine it into one log, and it becomes the product of what you were adding before. So this will be one natural log of x times 3, which is 3x. So this addition symbol indicates a product. You're going to have multiplication. If that was a subtraction, that would indicate that you would have division or a fraction. All right, then the next side, the right-hand side, we have the power rule, which says that the coefficient can come up and become an exponent on whatever you're taking the log of. So this is equivalent to the natural log of x squared. This is how you want it to look if you want to be able to undo the logs on both sides. So you have the natural log on each side, and that's it. There's nothing in front of the natural log. There's nothing added or subtracted. You have one natural log on each side. If that's the case, then the natural logs are going to undo each other, and you can simply rewrite the equation without them. So solving this equivalent equation will give you the answer to your original equation. So we have a power, this x squared. So we want to move everything to the same side, set it equal to 0, and then see where we can go from there. We can see that both terms have an x in common, so we would start by factoring that out. And then we can set each factor equal to 0 separately and solving. So we see x is 0 and x is 3. All right, so now what we want to do is we want to check both of these. The reason we know that we have to check is that we started our equation with logarithms. So if you start your equation with a log, if you start your equation with a radical, or if you start your equation with a fraction, in those three instances, you need to check your answers because you might get one that's not valid. So that's what we're going to do here. So we're going to check the x equals 0. So this is our check. When we're checking, remember that what is going on here is that the domain of the logarithm has to be positive. So in order for this to be a valid solution, what we're taking the log of has to be positive. So we need x to be greater than 0. So we want to know, is 0 a valid solution? Well, let's plug 0 in. Is 0 greater than 0? No, this is false. That means that 0 is not a valid solution. All right, now we're going to check x equals 3. So again, we're taking the log of x, so that has to be greater than 0. We think our solution is 3, so we're going to plug that in. Is that true? Yes, 3 is greater than 0, so this checks. The other things we're taking the log of is a 3. Well, that doesn't have a variable, so we don't have to check that. We're also taking the natural log of x. Well, that's the same as the first thing we checked. So x equals 3 is a valid solution. Another way you can check this is simply plug the number into your calculator in the original equation, and if you can get it to balance out, then it's a valid solution. If it tells you error, then it's not a valid solution. All right, 6b, convert the equation to exponential form, then solve for x. So realistically, they might not have all of these directions. They could just say solve, and you would have to know that you want to start by converting the equation to exponential form. So since we only have one log, that is kind of the clue that you want to switch to exponential form. So to do that, you want to first identify the base. So the base is 3. So you write down the base. When you're doing exponential form, it's the base raised to an exponent is equal to something. The way you find all these pieces is you start by identifying the base, then you go across the equal sign, and that is your exponent. That's the next box to fill in. Then you go back across the equal sign, and the next box you're filling in is x squared plus 5. So identify the base and then go back and forth across the equal sign to find the other parts. And then you just solve this equation. So 3 squared is 9. I'm trying to get the x by itself, the x squared. So I'm going to subtract 5 from both sides. So this means x squared is equal to 4. I take the square root. Don't forget that if you put a square root in a problem, you have to put plus or minus. So x equals plus or minus 2. Now I started this equation with a log, so I need to check my answers. So I'm going to check each one. First, I'm going to check x equals positive 2. So I am taking the log of x squared plus 5. So x squared plus 5 has to be greater than 0. So now I'm going to plug in 2 and see if that's true. So 2 squared plus 5 is greater than 0. That's 4 plus 5, which is 9. So the question is 9 greater than 0? Yes. So 2 checks. Now I'm going to check negative 2. So if I plug in -2, we have the same thing. X squared plus 5 has to be greater than 0. If I plug in -2, -2 squared is a +4. And then we get the same thing, 9. We already know that 9 is greater than 0. So -2 also checks. So in this case, both of our solutions check. So x equals 2 or -2. Okay, number 7. So find the vertex of the quadratic function. So there's two different ways to find the vertex. One way is to complete the square and find the vertex by putting this into vertex form. Another way is to use a formula to find the x value, then plugging that in to find the y value. I like to do the second method, so that's what I'm going to show here. Sometimes if you do the complete the square method, it can get very messy depending on what numbers you're given. So this seems to be the easiest all the way around. So to find the x value of the vertex, you use the formula -b over 2a. A is in front of x squared, so a is 2. B is always in front of x, so that's -8. So we're going to have -b, so -8 over 2 times a, which is 2. The two negatives will make a positive, and 2 times 2 is 4, and 8 divided by 4 is 2. So the x value of the vertex is 2. To find the y value of the vertex, you simply plug in the x value that you just found and then simplify. So plug in x value. So y equals 2 times x squared, x is 2, minus 8 times x. So 2 squared is 4, times 2 is 8. 8 times 2 is 16, so we end up getting 8 minus 16, which is -8. So there's my y value. So now putting that together, 2, -8 as an ordered pair is my vertex. Make sure you write it in the correct form. So you need to put this as an ordered pair in order to get full credit. Otherwise, you have not done what it asks you to do. All right, part B is to sketch the graph. Let me make this a little bit smaller here. Okay, so we want to sketch the graph. It's the same function as above in part A. So I'm going to remind ourselves of the vertex. You always want to have the vertex when you're graphing a parabola. So 2, -8 is the vertex. You should know the shape, the basic shape of this. Since it's a positive right here, the coefficient is positive, that means it's going to be going up, and it's kind of shaped like a U, so it's a parabola. So we know the vertex in this case is the minimum value. It's the lowest value, so it's going to be going up. Then we need to find at least 2 other points to graph this, kind of accurately. You can pick a random x, plug it in, and find the y value. Or you can find the x-intercepts, since the x-axis is given here, and plot those. So I would probably try to find the x-intercepts. And remember, that just means you're going to let y equal 0. So that would be 2x squared minus 8x equals 0. And then solve. So we could factor out a 2x. That would leave x minus 4. And then we set each factor equal to 0 and solve. So if we divide by 2, we'll get x equals 0. Here, if we add 4, we'll get x equals 4. So the intercepts are 0, 0, and 4, 0. So we can plot those. And then once we have the 3 points, including the vertex, we can connect those and make it look kind of like a U. And that would be a good sketch of the graph. It doesn't matter if the lines are perfectly straight, as long as it looks like a U at the bottom. You would not want it to be a sharp edge like that, because if it looks like a V, then that is an absolute value equation, and so that would be counted wrong. So make sure it doesn't look like a V, it looks like a U. Other than that, if you have 3 points on the graph, including the vertex, you should be fine. One other thing I want to mention here is that even though it doesn't ask us to find this, it could ask on the final about the axis of symmetry. So don't forget about the axis of symmetry. The axis of symmetry is the vertical line that splits the graph in half. It goes through the vertex. So here, the vertex is at 2, -8. So the axis of symmetry, if they ask you to include it on the graph, is that vertical line. And if they ask for it as an equation, you would say it's x equals 2. The axis of symmetry is always x equals the x value of the vertex. So just in case that's included on the final, that's how you find that. And I guess the other thing while we're doing that is the minimum or maximum value. This one, again, since that first, the leading coefficient is positive, you're going to have a minimum value. And the minimum value is always the y value of the vertex. So the minimum is -8. Okay. All right, number 8. So let me increase the size here a little bit. Okay, so 8a, identify the slope of the line graphed above, and then 8b, we're going to write an equation for the line in point slope form. So here, the slope of the line, we have to get 2 points. So you want to look for points that are clearly indicated on the graph. So here's one that goes through an intersection point. So that point would be 0, 1. And then the other one I see is right here. It goes through intersection point, and that's at 5, 3. So there are 2 points that we can use. We can give the slope in 2 different ways, or we can find it. So we can either use the formula. If you wanted to use the formula, it's y2 minus y1 over x2 minus x1. And if they just gave us the points, that's what we would have to do. But since we have the graph, we can actually just count. So the geometric interpretation of the slope is rise over run. So to get from this point 0, 1 to the point 5, 3, I'm going to have to go up 1, 2 units. So up is positive, so the rise is 2. And then to continue to move to the point 5, 3, I'm going to have to go right 1, 2, 3, 4, 5 times. So that would be a run of 5. So the slope is 2/5. If you use the formula with those 2 points, you would see that you get the same thing. Okay, and so part B is write an equation of the line in slope or point slope form. So in order to do that, you first have to know what that form is. So that is y minus y sub 1 is equal to m times x minus x sub 1. So that's the equation of the line. So m is 2/5. Okay, and then you just have to pick the point that you want to use to plug in for x sub 1 and y sub 1. So I'm just going to pick this point here, 0, 1. So y is 1, x is 0. And there you go. That's in point slope form, so you're done. So make sure you memorize the different forms of the lines. This could have also asked for it in slope-intercept form. So if it had asked for it in slope-intercept form, you could have given that as well because you have the y-intercept. So if they wanted it in slope-intercept form, that's y equals mx plus b, where b is the y-intercept. The y-intercept here is 1. So in this case, it would have been y equals 2/5 x plus 1. So if it would have asked for it in slope-intercept form instead, that would be the answer that you would have given. So as you're working through these, just try to think, okay, what other alternatives could they ask given the same information, because the final exam, will be similar, but it could have some variation on what's shown here. All right, number 9, solve the equation. So for this one, you want to solve it by first getting rid of the fractions. So to do that, you want to find the least common denominator. It's been a really long time, like since the beginning of the semester, since we've done these. So you might need to go back and re-watch the video related to this so that you can get a better understanding if you don't remember this one. But what we did here is we factored the denominators fully. So in this case, both denominators are already factored. But if they're not, you start by factoring the denominators. Then what you do is you include each different factor in your LCD. So the first factor I see from the first denominator is x plus 2. So I need to include that factor. The next denominator has the factor x. X is different than x plus 2, so I also have to include that factor. That's all my denominators, so that's my LCD. Once you find your LCD, you want to multiply both sides of the equation by that entire LCD. So times x plus 2 times x plus 2. If you have more than one term on a side, you're going to be distributing that LCD to each term. So let's see what's happening. 1 over x plus 2 times x plus 2 plus 1 over x times x plus 2 equals 3 times x plus 2. So the black part is the original equation. The red part is me distributing the LCD to each term on each side. What should happen here is the denominators of each fraction should completely cancel out with one of the parts of the LCD. So in the first fraction, the x plus 2's do cancel, and it leaves us 1 times x. 1 times x is x, so that's all that's left from the first fraction. In the second fraction, the single x cancels with the other single x. So all that's left is 1 times x plus 2. Well, that's just going to be x plus 2. Equals, here we have 3 times x, so that's just 3x, times x plus 2, and then we just distribute that 3x. So we're going to get 3x squared plus 6x. Combine like terms on each side, so x plus x is 2x. That's the only thing that we have right now. Since we have a power and we have more than one variable, we're going to move everything to the same side and set it equal to 0. Since my 3x squared is on the right and it's positive, I'm going to move everything that way. So I'm going to subtract 2x, subtract 2. So that's going to give me 3x squared plus 4x minus 2 is equal to 0. And now I need to solve that. We're going to solve that by trying to factor. If we try, we have to figure out what multiplies to get -6 and adds to get 4. You'll find out that it doesn't work. It's not going to factor. So that means our only option is to use the quadratic formula. So you need to have this memorized. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So a is 3, b is 4, and c is -2. So we're going to plug those in where appropriate. So we have -b, so that'd be -4, plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 3, times c, which is -2, all over 2 times a, which is 3. So now our goal is just to simplify this as much as possible. So we'll have negative 4 plus or minus the square root. 4 squared is 16. Negative times a negative is a positive. We have a negative 4 times a negative 2. So since we have two negatives, we're going to get a plus. 4 times 3 is 12, times 2 is 24. All over 2 times 3 is 6. Continue to simplify under the radical. So negative 4 plus or minus the square root of, that's 40 over 6. You should try to simplify this radical now. So your calculator might do this for you, and if it does, great. If it doesn't, and you have to do it by hand, remember that we did this by doing a prime factor tree. So 40 could break down into 4 and 10. 4 breaks down into 2 times 2. 10 breaks down into 2 times 5. Those are all prime numbers. Since it's a square root, we look for groups of 2. So there's a group of 2. And the other 2 don't have a pair. So the group of 2 2's comes out as a 2. And then the 2 and the 5 multiply back together and stay under the radical. So the pairs come out, the singles stay under. So that's now going to be negative 4 plus or minus 2 square root 10 over 6. And now you can reduce this if all three of these terms have a common factor. They can all be divided by 2. If they weren't all divisible by the 2, then you couldn't do it. So like in this previous example, you could not simplify by 2 because you have a 4 and a 6, but there's nothing here. Okay, so this divided by 2, negative 4 divided by 2 is negative 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So we'll have negative 2 plus or minus. If it's 1 square root of 10, I don't have to write the 1. It's understood to be there, over 3. You did start with fractions, so you have to check these just to make sure it won't make the denominator 0. Neither of these will make the denominator 0. The first fraction, negative 2 would make the bottom 0. And in the second fraction, 0 would make the denominator 0. So these are both valid solutions. Number 10. Find the equation of an exponential function that passes through the points 0, negative 1, and 2, negative 9. Then determine if the function is increasing or decreasing. Okay, so the first thing you want to look for is, do I have a y-intercept? You know that you do if your x value is 0. So if you look at this first point, since the x value is 0, this is a y-intercept. Okay, so that's important. You always want to start by using that equation or that point. A generic exponential function is given by y equals a times b to the x. Your goal here is to find a number for a and a number for b, and then write your equation with numbers for a and b, and y and x are going to be your variables that are left. So we're going to use that first point. So 0 is x and negative 1 is y. So negative 1 is equal to a times b to the x, which is 0. Anything to the 0 power is 1. So b to the 0 is 1. A times 1 is a. So we're going to have negative 1 is equal to a, or a equals negative 1, right? So here we've done half the work. We found what a is. You always will find a when you find the equation using the y-intercept. That's always what you will find. Then you're going to use that and the second point to find b. So our second point, let's write our general form here. So y is negative 9, a is negative 1, b we don't know, and x is 2. So to get the b by itself, we want to divide by negative 1. So we will have b squared is equal to positive 9. square root both sides, plus or minus. So b is equal to plus or minus 3. Okay, so now you need to know the following. B is positive, except b cannot be 1. If b is 1, then this is actually not even an exponential function. So b has to be positive. So because of that, it can't be the negative. So that means b must be 3. All right, so now we have a value for a, we have a value for b, so we can write our function y equals a times b to the x. That is what you want to give as your solution. Now we want to decide if the function is increasing or decreasing. So there are several things that you would have to remember in order to determine this. So I can go over all the rules, but really the easiest thing to do is just take those 2 points and plot them and see if it's going up or down as you move from the left to the right. So that's what I'm going to show you how to do here. That is the easiest way to determine this. So 0, -1 would be here, and then 2, -9 would be like, I don't know, somewhere way down here. Okay? If I'm going from the left to the right, you can see from the left to the right, the point is clearly going down. So this is decreasing. So take the 2 points that you're given, think about them on a coordinate plane, and is it going up or down from one point to the next? Going from left to right, and that's how you can determine that. Number 11. State the domain of the following functions in interval notation. So we have learned a few functions that we have to restrict the domain on, that there are exceptions for the domain. So one was a fraction. If we saw a fraction, we knew that the denominator cannot be 0. So that means you set the denominator equal to 0 and solve. Leave that number out of your interval notation. Okay, the second one we talked about were radicals, and specifically I should say square roots. So this doesn't apply to cube roots. So let's be specific here, square roots. So if you see a square root, remember that if you take the square root of a negative, then you have an imaginary number. So here, you're going to take whatever is under the radical and it has to be greater than or equal to 0. So it can be 0, it just can't be negative. Then you're going to solve that. So solve and write the answer in interval notation. Okay, and the last thing we had to look at that had a restricted domain was logarithms. So here, whatever you're taking the log of, has to be greater than 0. It has to be positive. So square root is greater than or equal to, log is greater than. If you don't have one of these 3 things, what we've talked about in our class is that you then have an unrestricted domain, meaning all real numbers, meaning -infinity to infinity. So in part A, we have a function. There's no fraction, there's no square root, and there's no log. So that means here, the domain is -infinity to infinity. All right, part B, we have a square root. That's case 2. Whatever is under the square root, so that's 5x minus 1, you take whatever is under the square root and you set that greater than or equal to 0. And then you solve. So we add 1 to both sides. So we get 5x has to be greater than or equal to 1. Divide by 5. So that means x has to be greater than or equal to 1/5. So that is your domain. X must be greater than or equal to 1/5. You need to write that in interval notation. If you're not good at that, then I would suggest drawing a number line, putting your number on the number line. So 1/5. X is greater than that. That means you're going to shade everything to the right. Greater than means to the right. Since it has or equal to, you're going to use a square bracket. So now remember, interval notation is left to right. The leftmost value is 1/5 with a bracket because it's or equal to. Comma, it goes to the right forever, so infinity. So that's your domain. Not negative. Positive 1/5 to infinity. So anything with the square root, that's what you do. Now remember, if it has a cube root, because this is tricky, people are going to get tricked on this. Let's say they put one with a square root or a cube root. If they have a cube root, the domain is negative infinity to infinity. So that's what you're looking for, is a square root. All right, part C, log. That's case 3. So whatever you're taking the log of, so that means whatever is in parentheses following the log, has to be greater than 0. So x must be greater than 0. Okay, so we've got x by itself, so now we just need to make sure we write our interval notation correctly. So here's 0. Since it's a greater than, that's everything to the right. This one gets a parentheses at 0 because there is no or equal to. So here, your domain, left to right, it starts at 0 with a parentheses, and it ends at infinity, so it doesn't really end, it goes to the right forever, right, with the parentheses. Remember, infinity and negative infinity always get parentheses. So that is what you're looking for. Whatever you're taking the log of has to be greater than 0. You set that, greater than 0 and solve. They didn't show you on the fraction, so we can do one really quickly just to kind of remind you. Let's say I have j of x is equal to 1 over x plus 5. So we won't make it real complicated. We just want a quick example. So here, this is a fraction. So you want to set the denominator equal to 0 and solve. So you would subtract 5 from both sides. You would get x equals negative 5. Remember, this is what x cannot be. So x can be everything except negative 5. So that means it goes from negative infinity to negative 5 with parentheses because you don't want to include negative 5. Union negative 5 to infinity. So this says it can be everything less than negative 5 and it can be everything greater than negative 5. Whatever value or values you're excluding will hug this U, this union symbol. And so that would be your domain. So those are the 3 things you're looking for. Any other function in our class that we've looked at has a domain of negative infinity to infinity. All right, I'm actually going to stop there for this first video. So that'll be the first half, and I will do the second half in a video in the next video.